Let's see one more example on joint probability distribution for continuous random variables. Okay, suppose you are being given a two-dimensional continuous random variable capital X comma y whose joint PDF is given by the 6x square y for x ranging between 0 and 1 and y ranging between 0 and 1 and 0 everywhere else. Okay, he has asked us to verify that the integral 0 to 1, I mean x and y ranging from 0 to 1, f of x comma y value is equal to 1. That's what he was asked us to verify. One is a prove that or show that kind. Remaining are that you have to find some probabilities, like some probabilities of x and y. Okay, of course, conditional probability also he has asked. Let's see how to handle this type of fraud. First one is anyways obvious. All of you can do it because it's just the integration. Substituting the integrand. Okay, 0 to 1, integral 0 to 1, f of x comma y dx dy. Both the limits for x and y are given to be 1 and 1 only. Even the function is defined only for x ranging between 0 and 1 and y ranging between 0 and 1. So it's nothing but 0 to 1, 0 to 1, 6x square y dx dy or dy dx. Anything is fine. So 0 to 1, I'm integrating with respect to x. X square becomes x cube by 3 into y from 0 to 1. So it would be what? Integral 0 to 1. Of course, there's a dy as well. Right? 6 by 3, which is 2y dy. Okay. On integrating, I'll be getting what? 2y squared by 2 from the limits is 0 to 1. Again, this value would be 1. So hence proved, not a big deal. All of you can do it, I'm sure. Okay. Coming to the second, third, fourth ones, which are very interesting to do. Okay. Coming to the second one, how will I do it is, of course, this is also partially obvious if you have seen my previous video. For x less than 1 intersection, y less than 3. Actually, it is from minus infinity to 1. X is ranging from minus infinity to 1. Y is ranging from minus infinity to 3. Of course, upper bound infinity plus infinity is being fixed to 1 and 3, guys. Okay, clearly in the problem for the variables. Okay. Yeah, dy dx actually inner limits are for y. So I should be a bit cautious. Of course, while integrating, not now. Anyways. Now, for the lower bound of x, I am being given 0, guys. So minus infinity to 0 also, the function doesn't exist. I can just tell you, minus infinity to 0 also. Dx, this is nothing but 0. Okay, nothing is there. Similarly, okay, I think it is not 1 less than. Just a second. I think I'm looking at a wrong problem. Yeah, this is being asked about. Second problem is asked about. The problem is different. That is, I'm being asked to find x between 0 and 3 by 4 and y between 1 by 3 and 2. Okay, so accordingly, I'll fix the limits. X limits are from 0 to 3 by 4. Y limits are from 1 by 3 to 2. Okay. Yeah. 6x square y dx. No, dy dx. Inner limits are for y, right? So accordingly, I'll be integrating and getting the answer. Again, this is not a big deal. Of course, I can check for the other ones as well. That is, I'm taking from, just a second. Yeah, I should again split this. 1 to 1 by 3 to 2 is there. Now I should be little careful. Okay. Integral. Y limits are from 1 by 3 to 1 I have to split. That is one integral. Of course, 0 to 3 by 4, no problem with the x. 1 by 3 to 1 to 3 also, 1 to 2 also I have to split because 1 to 2 also I have to split because the integrand is not there between 1 and 2. It's there from 0 to 1 only. Okay. Here it is 6x square y dy dx. Okay. Accordingly, I will integrate and get the answer. 0 to 3 by 4. 6x square y square by 2 from the limits 1 by 3 to 1. Okay. Yeah. So I can put the limits for y, right? Yeah. And then integrate x separately because both are constant limits only. So it would be 6 x cube by 3 from the limits 0 to 3 by 4. And then y limits are 1 by 2 is one value minus 1 by 3 whole square, 1 by 9 and minus 1 by 9 to is 18 is what I will have. So finally the answer of this integrand, let me write here, substituting x is equal to 3 by 4 whole cube. The answer I have with me would turn out to be 3 by 8. Okay, I have to split it from 1 by 3 to 1 and 1 to 2 because after 1 the function is not defined, guys. For value after y value after 1 the function is not defined. Now coming to the third one, which is very interesting, x plus y less than 1, like the previous case. Just see here, if I plot this region, it turns out to be this triangle where this line would be x plus y is equal to 1. This would be 0, comma 1 and this would be 1, comma 0, guys. That's it. That's my region of integration. Accordingly, I'll fix because double integral is always a region of integration. Okay. Yeah. The least value of y or x I will take outside the constant limits. I mean here to here, if I'm taking a vertical strip, that means a strip parallel to y-axis, then I'll be having the limits for y. If I'm taking a strip parallel to x-axis, then I'll be having the limits for x. Okay, right. Now, least value is on x-axis where y is equal to 0, guys. And then y is equal to 1 minus x. Okay, yeah. And the integrand is 6x square y dx, dy dx. Because inner limits are for. Again, I have the answer for it. Once the integrand limits are fixed, things are obvious, right? Yeah, this is an interesting question again. The previous one also x plus y is less than 3 also we would have done like this only. Yeah. The fourth one is again an interesting one. X greater than y. Okay. So for what all values x is greater than y, I should be calculating those. Or in other words, it is something like x greater than y. Okay. So I'll be fixing y limits from 0 to y or 0 to x, guys. Okay. 6x square y dy dx. Accordingly, I'll integrate and get the values. Okay. So integral 0 to 1. 6x square y square by 2 is what I'll have from the limit 0 to x. Dx this is, okay, right. This is equal to 2 1s, 2 3s I can cancel out or I can leave it as it is. 0 to 1, 3 x square. In the place of y also I'll be having x square dx. So finally I'll be having 3 x power 5 by 5, which would be 3 by 5. That's the answer that I have, by the way, is equal to 3 by 5. This is how I'll handle the case where x is greater than y. Okay. The last one, the conditional probability one, that is P of x less than 1 such that y less than 2. What exactly I'll be needing is P of x less than 1 intersection P of y less, I'm sorry, no P, y less than 2 I'll be needing. Y less than 2 I'll be needing given P of y less than 2. Okay. So I'll be needing this integrand. I can just write that integrand how it looks like. X less than 1. So 0 to 1 I can take. Y less than 2. So that also should be 0 to 1 only. Though I write it as 0 to 2. Between 1 and 2 the integrand doesn't exist. So it is 0 to 1 6x square y. Of course dy dx. Both limits are same. So I can put it the other way. 0 to 1, 0 to 1 to 2 6x square y. No, this is 0 dy dx by, how do I write this is integral, double integral of course, 0 to 1 and 0 to 1 only, this also, 6x square y dy dx. Okay. And finally, I can clearly see this integrand is 0. These two are same. So this value turns out to be 1, guys. This value turns out to be 1. It's very simple and very interesting, provided you understand the terminology. It's all about understanding the terminology. That's why I've done some previous videos on the terminology. Do check them out before going to the problems. Okay, that will make your job simple. Yeah, thank you.